Hello all, welcome to the Counting Well Exam Prep live session. Before we start the session, let me inspire you a bit. Remember that there is no substitute for hard work and your only limit is your mind. We know that exams are around the corner, the books are ready. So let's start practicing and revising the concepts before it's too late. For this, stay tuned to the session and build up the confidence to face your exams. In this session, I will take you through two chapters, Symmetry and Visualizing Solid Shapes from class 7. Let us revise some concepts from the chapter Symmetry. What is a line of symmetry or axis of symmetry? Axis of symmetry or line of symmetry is nothing but a line about which the two halves of the figure are symmetrical. For example, here you can see three shapes and three dotted lines. These dotted lines are nothing but axis of symmetry or lines of symmetry. Because along this line, if you fold these shapes, then you will get one side of the shape will overlap the other. A symmetrical figure can have one or more lines of symmetry. So it is possible for a symmetrical figure to have more than one line of symmetry. And the line of symmetry can be vertical, horizontal, or slant. So you can see for the heart shape shown here, the line of symmetry is vertical. Whereas for the figure shown here, the line of symmetry is slant. For a regular hexagon, for example, here we can see a pentagon with 5 sides. Okay. All the sides of this pentagon are equal, so it is a regular pentagon. So for any regular polygon, the number of lines of symmetry is same as the number of sides. So for example, here an equilateral triangle, it is nothing but a regular polygon. It has 3 sides, so there will be 3 lines of symmetry. For a square, so we know a square has 4 sides, so there will be 4 lines of symmetry. For hexagon, or we can say in particular for regular hexagon, where all the sides of that hexagon is equal, will have 6 lines of symmetry and so on. Let us see what is a rotational symmetry. An object or shape is said to have rotational symmetry if it looks exactly like the original object or shape after some rotation. So here, for example, you can see a square, okay, and you can see a fixed point here. And if we rotate this object along this fixed point or around this fixed point, then we say that the shape of this object remains same after some rotation. So this center point is nothing but called the center of rotation, or it is a fixed point around which the object is rotated. So for how many places will this object will look same? We'll check this out. Now the angle through which an object or shape turns or rotates is called the angle of rotation. For example, here you can see an object with two intersecting lines. So the two intersecting lines makes an angle 70 degree as shown. If we rotate this by 180 degree, we'll see the object takes the same position or it looks the same after 180 degree rotation. So 180 degree is called the angle of rotation. So when the object is turned completely by 360 degree, the number of times an object looks exactly the same is called the order of rotation. So if we start rotating this object by 180 degree, we'll get the object looking exactly the same. Again, if we rotate this by 180 degree, the object will take the same position. So how many times have we rotated the object? We have rotated the object 2 times by 180-degree angle. So we say the order of rotation for this object is 2 with angle of rotation 180-degree. In case of this square, we can see if it is rotated by 90-degree, then it will take same position. Again, if it is rotated by 90-degree, it will take same position. Again by 90, same position. So there will be 4 times an object looks exactly the same, or the square looks exactly the same. So the order of rotational symmetry for this object is 4 and the angle of rotation is 90-degree. Now let us see what is line symmetry and rotational symmetry. So a circle shape is a special case with both rotational and line symmetry because it is having infinite number of lines of symmetry. So here you can see all the dotted lines are nothing but lines of symmetry, and we can draw infinite number of lines of symmetry for a circle. Also, it has rotational symmetry because no matter by how many angle we rotate, the circle will look exactly the same, and the center point, which is the fixed point, is called the center of rotation. Now some figures show both rotational symmetry and line symmetry, and such example is circle. But some figures show rotational symmetry but no line symmetry. For example, you can see here a parallelogram. There is no line of symmetry because we cannot draw a line for this parallelogram such that if we divide it into two halves, or if we fold the figure along this line, then the two parts are equal. We cannot find any such line. So it is not having line symmetry as there is no axis of symmetry for this parallelogram, but it shows rotational symmetry because if we rotate this figure by 180-degree, then it will take the same position or it will look the same. So the rotational symmetry will be of order 2, or the order of the rotational symmetry is 2 for this parallelogram. In some cases, figures show line symmetry but no rotational symmetry of order more than 1. Note that every figure having line symmetry will have rotational symmetry of order 1 because after 360-degree rotation, that object will always look the same. So the order of rotational symmetry is 1 for any figure having line symmetry. But for some figures having line symmetry, there cannot be rotational symmetry of order more than 1. For example, you can see the shape shown here. It has one line of symmetry shown by the dotted line L, but no rotational symmetry of order more than 1. Because after a rotation of 360-degree only, the object will take the same position or it will look the same. Let us revise some concepts from visualizing solid shapes. Now, what is the relation between a 2D and 3D shape? A net is an outline of a 3D shape in 2D, or a net is a 2D representation of 3D solid shape. So here you can see a 3D shape, which is a cube. If we open this 3D solid shape by cutting along with the edges and we lie it down, and this will be the 2D representation of this shape. So this is nothing but the net of that cube. So net is nothing but the outline of that cube in 2D. Let us see net of a die. The sum of the numbers of an opposite faces should be always 7 for net of a die. Let us see some net of solid shapes like cube, cuboid, cone, cylinder, prism, pyramid, and octahedron. So here you can see a cube has 6 faces. So there will be 1, 2, 3, 4, 5, 6. 6 squares. For a cuboid, you can see how it is opened and made in the 2D representation. For a cone, the circular shape will look like a circle, flat circle, and this curved surface of the cone will look like this in 2D outline. Similarly, for a cylinder, if you cut this circular shape, then you will get the 2D representation, and the curved surface will become a rectangle as shown here. Similarly, for a prism, we can see the base and the top of the prism as the 2 triangles and the 3 rectangles. Similar, we can see for pyramids and for octahedron. Let us see how to draw solid shapes or 3D solid shapes. We can draw it using oblique sketch or isometric sketch. In oblique sketch, what we are going to do? We are going to draw 3D solid objects on a plain piece of paper. Okay. So an oblique sketch focuses more on the front face of the 3D shape. So here you can see the oblique sketch of a cube. Isometric sketch is made using isometric dot sheet. So what is isometric dot sheet? It is nothing but a sheet dividing the paper into small equilateral triangles made up of dots. So it is nothing but a sketch drawn for 3D objects on an isometric dot sheet. And the measurements in the sketch are same or proportional to the size of 3D object. So here you can actually see the dimensions of the 3D object, but in oblique sketch you cannot figure out it properly. Now different combinations of different solids form another solid shape. So here you can see the combination of a cone and hemisphere forms a shape as shown here. Similarly, you can see a cuboid is there and one more solid shape is there, forming the solid shape as shown here. Similarly to hemisphere and one cylinder, you can see the shape of a capsule here. Let us see how to view solids by cutting and slicing and by shadow. So when an object is cut vertically or horizontally, the flat surface of each cut is called the cross section of an object. So the cross section of any object will have different shapes depending upon its shape and the way it is cut. For example, here you can see a cube is cut in this way. So the cross section will be of the shape of square. If the cylinder is cut like this, then the cross section of this cylinder will be circular in shape. Note that the cross section of an object is the 2D shape, means it only shows the outline. Now, if the cylinder is cut in this way, the cross section will be a rectangle. If a sphere is cut in this way, then the cross section will be circular in shape. So you can see different objects may have the same cross section, and we can cut the object and take its cross section. And there are many ways to cut an object. So the cross section will depend nothing on its shape and the way it is cut. Also, the shadow of a three-dimensional object is two-dimensional. Like we have the cross section of an object, and the shape of the shadow is same as the shape of its cross section. So you can see if you take the cross section of a cylinder in this way, then it is a circular in shape. For a cylinder with cross section taken vertically, it looks like this. For a cube cross section taken like this, it will look like this. And if for a sphere we take the cross section, it will look circular in shape. Now we can visualize solid shapes by taking look from different angles, or we can look the different objects from different angles of view. So there are basically three views. One is front view, second is side view, and third is top view. And it can provide a lot of information about the shape observed, like the shape of the solid or the shape of the different solids combined. For example, here you can take the solid as this one. If it is viewed from the front, okay, from the front, then you can see there will be 5 squares arranged like this. If you view it from side, means from this angle, then you will see 3 squares placed one above the other. If you see from the top, then you will see there are 3 squares. So you can see this is first square, second square, and third square. So the top view will look like this. Now let us observe the solid as shown here. The front view means we are viewing this object from this angle. So we'll get a square and a triangle on it. From top, if we see, we can see a square with both the diagonals. Now let us see some tricks for the exams. Okay. A figure can have one or more than one line of symmetry. So whenever you are asked to find the number of lines of symmetry, then you should make sure that you do not miss any other line of symmetry. And you should check whether drawing a line divides the figure into two equal parts or not. Let us see what is order of rotational symmetry. So when you rotate an object or figure by one complete revolution, okay, or by 360-degree, the number of times the figure looks the same or takes the same position is called the order of rotational symmetry. So every figure or shape has rotational symmetry of order 1. So no matter whether it has line symmetry or not, if you rotate any shape or figure by 360-degree once or twice or thrice and so on, you will always get the order 1. So we consider figure to have rotational symmetry only if it has rotational symmetry of order more than 1. So we say a figure has rotational symmetry only when we are talking about rotational symmetry of order more than 1. Means if rotational symmetry is 2, then we say the figure is having rotational symmetry. Or if the order is 3, then we say the figure has rotational symmetry and so on. The shape of the cross section of a solid depends only on the way it is cut. So if in the exam it is asked whether we can get a circular shape by cutting the cylinders, then it is yes. If you take the horizontal cut of the cylinder as shown here, then you will get the circular shape. If you take a vertical cut, then you will get a rectangular shape. If you take slant cut, you will get the oval shapes as shown here. So it depends upon the way it is cut. So the shape of the cross section is depending mainly on the cut of that shape. Now, if you want to identify different shapes that form the given shape, you have to look for the known shapes. If you want to find the number of cubes forming a solid, you have to view the solid from different angles and then you have to count the cubes which will be hidden from the view. Okay, you can find the top view, you can find the side view, you can find the front view. So let us see how many cubes are visible and how many are hidden. You can see there are 3 cubes visible and one is hidden, and that is below this cube. So there are how many cubes? There are 4 cubes. Now to identify the net of a solid, check whether any face of the solid matches or if any part resembles the curved surface of the solid. For example, here we have curved surface as cone and the bottom surface as a circle bottom. So the net will be the combination of these two faces, correct? Now let us see what are some common mistakes a student may do. First, a figure can be either symmetric or asymmetric but cannot be both. Okay, we can call a figure either symmetric or asymmetric. In this case, we are talking about figure having line of symmetry or not. If the figure has line of symmetry, it is a symmetric. No matter whether it has one line of symmetry, two lines of symmetry, or three. And it is said to be asymmetric if it cannot have any line of symmetry. But note that every object has rotational symmetry of order 1. Figures having line or lines of symmetry are symmetric, whether figures having no line or line of symmetry are asymmetric. So here you can see the shape is symmetric because if you fold this figure along the dotted line, we'll get the overlapping parts, and that overlapping will be exactly the correct overlap. Whereas this figure is asymmetric because we cannot find a dotted line which divides the figure into two equal shapes overlapping each other once we fold the figure along the line. Remember that line of symmetry is not always horizontal. It can be vertical, horizontal, or slant. For example, here you can see the letter X. What do you think are the lines of symmetry? Whether it is vertical or horizontal or slant. If we draw a line like this, okay, and if you fold this letter along this line, you will get two equal parts. So there is a horizontal line of symmetry. Now if we take the line like this, and you can see the two parts are equal, so it has vertical line of symmetry as well. So the letter X has both the horizontal and vertical line of symmetry, and not only horizontal line of symmetry. Let us see number of lines of symmetry for a regular polygon. We should not find, or we should not draw lines of symmetry to find whether the number of lines of symmetry is 1, 2, or 3. Just note which regular polygon it is. If it is equilateral triangle, the lines of symmetry is 3. If it is a regular pentagon, the lines of symmetry will be 5. If it is a regular hexagon, means having all the sides equal, then it is a regular polygon, and the number of lines of symmetry will be 6 for a hexagon. Remember that each polygon has as many lines of symmetry as its sides. So for a regular hexagon, it has 6 lines of symmetry. Also note that a rotational symmetry is not same as line symmetry. An object or shape has rotational symmetry if it looks exactly the same as the original object after same rotation. Whereas if an object has line or lines of symmetry, it is said to be having line symmetry. So rotational symmetry is not the same as the line symmetry. Both are different concepts. So you can see this figure has only one line of symmetry. So it has a line symmetry. So here you can see among this line or along this line, if you fold this figure, you will get two equal parts. Also, after one rotation, it will look exactly the same or takes the same position as the original one. So the order of rotation symmetry is 1. So the figure has line symmetry but no rotational symmetry of order more than 1. So here you can see how the figure has rotational symmetry. Note that you have to take complete revolution of 360-degree to get the same position. So the order of rotation symmetry is not more than 1. Now, the order, whenever we say, it is always for rotational symmetry and not of rotation. Okay, whenever we say order of rotational symmetry, it is not the order of rotation. So in a complete turn of 360-degree, you have to check how many number of times an object looks exactly the same as original object, and that will be your order of rotation symmetry for that object and not the order of rotation of that object. As I told you, every object has rotation symmetry of at least order 1. So in a complete turn of 360-degree, the number of times the object looks exactly the same as the original one is called the order of rotational symmetry. So in a complete turn of 360, every object looks exactly the same as original at least once as we take one complete rotation or one complete turn. So every object has rotational symmetry of at least order 1. Let us see some common mistakes from the chapter Visualizing Solid Shapes that a child may do. A cube do not have a unique net. It can have number of nets. Okay, so there will be two conditions we should be satisfied for that. First of all, net of a cube is an outline. When folded, it should form a cube, and it should be made up of 6 squares only. If there is any one extra square, then it is not a net of a cube. So here you can see figure 1, 2, 3. These are the nets of cube because it has 6 squares. But now you have to check. There can be a number of nets for a die, but a net is always having 6 squares and opposite sides always add up to 7. These 2 points we have to remember whenever we are identifying net of a die. So here you can see we have 4 outlines. This is the net because the opposite faces add up to 7. So here 4 and 5 are opposite faces. 6 and 7 are opposite faces. 3 and 4 are opposite faces. That's why it is a net of a die. Now let us see second figure. This is not the net for a die because sum of the two numbers on the opposite faces is not 7. So here you can see 3 and 4 are the opposite faces. 2 and 6 are opposite. 5 and 1 are opposite. But they are not equal to 7 in each case. Only for 3 and 4 it is 7. Now let's just see third outline. Here we have 2 ones which is not valid. two faces having same number 1. That's why it is not the net of a die. Let us see the last outline. This is not the net because some faces may overlap each other. Okay. So you can see only first figure is net of a die and not the other three. While identifying the different views of solid, you should imagine how it looks from the top, side and bottom. So just imagine this solid shape. Remember, whenever you are viewing the solid or seeing the solid from the top, you will get a square containing 4 line segments in it, not a single dot or a square. So like this, you have to view the solid from the top. Next, if we look the solid from the side, it is same as the front view. We see a combination of triangle and a square, not a square or a triangle. So here it is solid when viewed from side. So this is the top view, not the second or third one. And this is the front or side view of the solid. Now let us see some exam tips for this chapter. First is you have to practice a variety of questions from NCERT books, other textbooks, and from previous year question papers. Then you have to note down all the definitions and properties. Then to check symmetry, you have to draw a line in the middle of the figure. You can also drive with vertical, horizontal, and slanting lines. In any case, if the figure on each side of the line is equal, then the line is line of symmetry and the figure is symmetrical. Always you have to draw a rough sketch to represent the question. This will help you to identify the property to be applied. You should always read the given question carefully and understand it. At the last, you have to check whether you have answered all the questions and parts of question. I hope this session was helpful. And if you want to quickly revise the concepts, practice some extra sums, and also take a quick test, then Counting Well exam prep kit is here. It will let you quickly glance through the major concepts of your chapter. You can also glance through the solved examples, practice questions, and chapter assessments. You will also understand the tips and tricks, common errors that you make, etc. Over 75,000 students trust Counting Well for their math learning, and even without the exam prep kit, they can learn every day on the app by diving deep into every chapter. You can download the app from the App Store or Play Store. Also, stay connected to our channel, Counting Well, and learn more tricks and tips and ways to avoid them. We will be revising the chapter Simple Equations and Algebraic Expressions from Class 7 in our next live session tomorrow on 17 February at 6:30 p.m. Until then, see you in the next session. Keep learning and keep growing. Thank you.